So let's begin this one by doing a simple equation that we already know. 3x minus 2 equals 19. I want to solve for x, so let's first do what?
Take away the bum in the corner.
Get rid of the bum. Okay, yeah. So you want to get x by itself because x is the movie star, right? X is the movie star, 3 is the movie star's buddy. This loner over here, you don't care about this guy, bum at the corner. Let's get rid of that guy. So the way to get rid of a minus 2 is to do the opposite, plus 2. And what you do to one side, you do to the other side. And let's rewrite our equation. There's a 3x left over on the left side of the equal sign. And 19 plus 2 is 21. And of course, you have a 3 times x. You don't want that 3 times x, so what do? You divide by 3 to get rid of the multiplication of 3. What you do to one side, you must do to the other to maintain the balance. And you have x equaling 7. X equals 7 is the answer to that one. And we already knew how to do that. No big deal. But what I wanted you to do now is to solve this new equation. Kx minus g equals r. Kx minus g equals r. Now you're probably thinking, what the heck's going on? There's not even any numbers involved right here. That's correct. There are no numbers. But we need to solve. And it depends what they're telling you to solve for. Right here, they're telling you to solve for x. So we're going to do the same exact process. We want to get x by itself because they're telling us to solve for x. Now, if they would say solve for g, you'd want to get g by itself. If they say solve for k, you'd want to get k by itself. But because it says solve for x, we need to solve for that x value. So let's begin by plus g. Again, same concept. If you're solving for x, x is what's important. X is the movie star. K is with the x, so that's like the movie star's buddy. G is all by itself. The loner, you don't care about this guy. So let's get rid of that g first by going the opposite of minus g, which is plus g. And that will cancel out. And what you do to one side, you do to the other. So you're going to go plus g over here. Now, r plus g, those are different terms. Could you add r plus g?
Yeah.
No, you can't, right? What you're going to do is just rewrite it. It's like saying I have a marker plus 1 eraser. You can't add them together. Like, what do you have? 1 marker plus 1 eraser is exactly that, 1 marker plus 1 eraser. It's not 2 markacers, right? So what you have is kx is left over on the right side, on the left side. And on the right side, r plus g, you can't do it, so just rewrite it, r plus g. Now for my final step, I need to get the x by itself, and there's obviously a multiplication of k right in front of it. So I need to get rid of that k by doing the opposite, dividing by k. And what I do to one side, I do to the other side. Now I could do it to the whole thing like this, divide the whole thing by k, and that is your answer. X equals r plus g, all divided by k. Or you could split the divisor, the k, you could split it to each term. So you could split it to each term, and it'll become 2 fractions. So you could write it like this. X equals r over k plus g over k. Either one's correct, either one's totally fine. So this one or this one. Now, I hope we kind of understand that. But there is an extra detail that we want to state on this particular solution. And that detail is that the k value cannot be 0. Okay? Why is that? Because if k were equal to 0, and if you divide anything by 0, it would make it all undefined. Okay? So whenever you have a denominator down here, you don't want that denominator to become 0. So we also need to state this. But k cannot be 0. So this is your answer, but you need this additional statement. But k cannot be 0. What do you guys think? So solving for any given variable, I want to give you an equation that has tons of variables, right? X, Y, Z, A, B, C, Q, R, S, who knows? You have a bunch of different variables, and you're going to solve for the variable that they tell you to solve for. Now, what does that mean? You get that letter by itself on one side. Now, if you do end up with the denominator with a variable in it, then you have to state that that denominator cannot be 0. So let's focus in on that concept right there. Let's say I was solving an equation. Let's say they told me to solve for r, and I have r equals, let's say I solved for r, and I get the answer r equals 2g minus 3 over x. Okay? So let's say this is my answer. But because I have a variable in the denominator, I need to state something additional. I need to state, but x cannot be what? X cannot be 0. Does everybody understand that additional statement? X cannot be 0. You got to throw that into your answer. Let's say you were solving for z. Yeah, you're solving for z, and you do all this math, and you get a final answer. Z equals, let's say, 5k over x minus 3. So if you do have that as an answer, let's say you're doing all this math, you're trying to get z by itself, you do the opposite, you add, you subtract 3, you divide by, blah, blah, blah. You end up with this as an answer. Z equals that answer right there. What do you need to state in addition to that? But what? But x cannot equal 3. I know some of you are thinking, wait a minute, shouldn't it be x cannot equal 0? Again, it's what will make the whole entire denominator 0. So what you should do is technically think this. Okay, I don't want this to be 0. So you're going to do this on the side. You're going to say x minus 3 should not be 0. Right? And then you actually solve this blue equation that cannot be. Right? So you would go plus 3, x comes down, but it's not an equal sign, it's a cannot be equal to sign. X cannot be equal to 3. So that's the additional statement you put. What do you guys think? So let me actually jump to the homework here. So here's the homework, 2.8 WSP. I already have another video explaining the odd ones, so I'm going to jump to the even ones. And again, they give you an equation with many variables in it. On this one, they tell you to solve for W. Again, the for W is just simply telling you that you want to get W by itself. All right, so W is clearly on the left side or the right side of the equal sign. Where's W at?
Middle.
It's in the middle?
No.
Here's the middle. It's the equal sign's the middle. Where's the W at?
Left.
It's on the left side. Is it by itself on the left side? No.
No.
W is the movie star. 6 is the movie star's buddy. This guy is the bum at the corner. Let's get rid of this guy first. How do you get rid of a minus y? Add y, plus y. And what you do to one side, you must do to the other, plus y over here. Now, notice 2z plus y, those are not like terms. Now, if it were a 2y plus y, that would be a total of 3 y's. But you have a z and a y, you cannot add z's and y's. So you're just going to have to rewrite it. So on the right side, you're going to have 2z plus y. And on the left side, what do we have left over? 6w. You bring that down, 6w. So you almost have w by itself. There is a 6 times right in front of the w. So you need to get rid of that 6 times. So you're going to divide by 6 and divide the whole thing by 6. So there's your answer. W equals 2z plus y, all divided by 6. Or you could also say that w equals 2 over 6 with the z right here plus y over 6. So this is a good answer. This is also an acceptable answer. And why would I want to split the denominator of 6? The division of 6, you could split it to each of these. And the reason why you want to split it to each of them is because 2/6 could be reduced. So if you wanted to, you could reduce that 2/6 to become 1 over 3. So another possible answer is w equals 1 over 3 with a z on top or a z on the side plus y over 6. So any of those 3 are acceptable answers. Now let me ask you this. What's in the denominator of these answers? 6. Is there any way that that 6 will magically become a 0? No. Does it have a 6x or a 6z or a 6a? No. So there's no variable, so there is no additional statement to say. Right? You don't have to say, oh, y cannot be -3 or y cannot be 0. Because 6 is the denominator, that'll never be 0. So this will never be undefined, so that's a good enough answer. Okay? Probably this first answer is the most common. Just put the whole thing divided by 6. Let's try number 4. So on number 4, they're telling us solve for s. Again, that's all this means right here. They're telling you to solve for whatever variable they tell you. Now they could say solve for u, they could say solve for g. Right here they're saying solve for s. So right here is s. That's a movie star right there. 9 is the movie star's buddy. This guy you want to get rid of first. So let's get rid of that minus 5g by doing what? Plus 5g. Cancels out. What you do to one side, you must do to the other, plus 5g over here. So let's rewrite everything. On the left side of the equal sign, let me first bring down the equal sign. On the left side, I have a 9s. On the right side, I need to think, could I actually do negative 4u plus 5g? No. Cannot do it, so I'm just going to rewrite it. Negative 4u plus 5g. So I almost have s by itself. All I need to do is one more thing. What is that other thing? Divide by 9, right? It's really a times 9, so we're going to divide by 9. Divide the whole thing by 9, and guess what? We're done. S equals negative 4u plus 5g, all divided by 9. Another way of writing it would be negative 4u over 9 plus 5g over 9, and that's perfectly acceptable also, but I'm going to just leave it like that. Let's try number 6. Before moving on to number 6, I do want to state that the denominator is a number, the number 9, and there's no way that 9 will magically become a 0. So there's no way that this is ever going to end up undefined. We do have to be careful for any time we have a variable down here, then you'd have to state an additional statement saying like, oh, like if you had an x right here down here, like let's pretend, right? I know that there's no x, but let's pretend there was a 9x in the denominator. Then you would have to say, but x cannot be 0, because that would make the whole denominator become 0, which would make the whole thing become undefined. But because there is no x down there, you don't have to put anything extra. It's just a 9 in the denominator, so you don't have to worry about the denominator ever being 0. Let's try number 6. On number 6, we want to solve for x. Where's the x at? Is it on the left side of the equal sign or the right side of the equal sign? The right. Is it by itself? No way. X is the movie star, right? They're telling us, hey, x is the movie star. Solve for x. You want to get x by itself. That's the movie star's buddy. This guy is the loner, the bum at the corner. Let's get rid of that guy by doing the opposite, by doing plus t and plus t. What you do to one side, you do to the other. Plus t. Now, if I do minus t plus t, that eliminates. And the equal sign's here. The kx comes down. And on the left side, you cannot add the 2p plus t. So you're just going to rewrite it. 2p plus t. So there's your new equation. We're trying to get x by itself. They want us to solve for x. X is clearly on the right side. I almost have it by itself. I need to get rid of that movie star's buddy, the k, the multiplication of k. So how do I get rid of the multiplication of k? I divide by k, right? Now, if it would have said x plus k, then I would get rid of it by subtracting k. But it's kx. That means x times k. So I need to get rid of that multiplication of k by dividing by k. Now, what you do to one side, you do to the other. So divide the whole thing by k, and you will be done. X is by itself on this side equals 2p plus t, all divided by k. That's your answer. Of course, you should write your x on the left side and the 2p plus t divided by k on the right side. Another acceptable answer is x equaling, separate the denominator k. You could split it to here and here. So it could be written as 2p over k plus t over k. So you could do this. I would probably just leave it like that. But regardless, whichever answer you decide to give, you also have to state something additional. What is that additional statement? But k cannot be 0. You have to write that down because you can't have undefined fractions. Okay, k is in the denominator. You have to say k cannot be 0. Let's move on, number 8. On this one, we want to solve for what? H. Solve for h. Where's h at? The left side or the right side of the equal sign? It's on the left. Is it by itself? No. All right, so we want to get h by itself. H is a movie star. What do I get rid of first? The g. How do I get rid of that plus g? Minus g. What I do to one side, I do to the other. Minus g over here. And I am talking about one side of the equal sign, I do to the other side of the equal sign. So d minus g, could I actually do that? No. So I just rewrite it. D minus g. Bring down the equal sign. And on the left side, we have this fraction with the h. 2/5 h equals d minus g. Now at this point, I want to get rid of the fraction. How do I get rid of the fraction? Multiply everything by the denominator. Emphasis on everything. Multiply everything by the denominator. The D times 5 and the G times 5. Let me put the times 5 right here in blue. So what do I have left? I have 2H equaling 5D minus 5G. What's my final step? Divide everything by 2. So you could just leave it like that, or you could split that denominator of 2 to each one. You could put this denominator of 2 to each one. I'm just going to leave it like that. So my final answer is H equals 5D minus 5G over 2. Do I have to give an additional statement? No, because the denominator is a nice, beautiful 2. There's no way that'll become undefined. Number 10, solve for A. I want to get A by itself. What do I do first? A is over here. So we need to get rid of the minus Q. So how do I get rid of a minus Q? Plus Q. Well, you do to one side, you do to the other side. So what do I have left? On the right side, I have K plus Q. And on the left side, so 3/4 A is on the left side and K plus Q is on the right side. So what do I do next? Multiply everything by the denominator 4. And I'm talking about everything by 4. This by 4 and this by 4. By the way, some teachers actually, instead of multiplying everything by 4, what they do, I might as well show you just in case you ever go to a different math class. They would say multiply this side by 4 and then multiply this side by 4. They do it like that. But still, if you do that way, you still have to distribute the 4 to both terms anyway. That's why I just jumped straight into multiplying everything by 4. So instead of distributing the 4, I just go ahead and multiply everything by 4. So I put a times 4 on the K, put a times 4 on the Q. The 4's cancel. I have a 3A equaling 4K plus 4Q. What's my final step? Divide by 3. Divide the whole thing by 3. And we're done. That's your answer. There it is. Could you separate the denominator? Yes, you can. If you want, you could separate it and make it a 4K over 3 and a 4Q over 3 as well. So you could separate that denominator of 3 to each of those. And no additional statement necessary on this one. Let's jump to number 12. On number 12, we're solving for B. And where's B at? The left side or the right side? It's on the left side of the equal sign. It's up here. Now, it's definitely not by itself. There's all kinds of junk all the way around it. So let's start getting rid of things. What would be the first thing you should get rid of?
4.
Now, notice the 4 belongs in the numerator of this fraction.
And
The 2, right? So if you're like, yeah, I want to get rid of the 4, well, you can't because it's up here on top of the fraction. First, you got to get rid of the fraction. Then you could get rid of the 4. Then you could get rid of the 3. So let's first start by getting rid of this fraction, which is really a divided by 2. We're going to multiply by 2. And of course, what I do to one side, I do to the other side, multiply the C also by 2. So those 2's cancel. And I have a 3B minus 4 left over. And I have a C times 2, which is 2C. And now you get rid of that minus 4 by going plus 4. And what you do to one side, you do to the other side, plus 4. And you got to ask yourself, here's my equal sign. Could I actually do 2C plus 4? No, because they're different terms. You could do 2C plus 4C, then that would be 6C. But that's not a 4C, that's just a regular 4. You can't add C's with numbers. So 2C plus 4 is going to stay the same, 2C plus 4. On the left side, you have 3B. Now you almost have B by itself. You need to get rid of that multiplication of 3 in front of the B. So what do I do next? Divide by 3. Divide the whole thing by 3. Cancels. B equals 2C plus 4, all divided by 3. That's a good answer. You could have also said that B equals 2 over 3 with the C right there and a plus 4 over 3. But I would leave it the first way. Number 14, the last one on this worksheet. Solving for L. So where's L at? Is it on the left side of the equal sign or the right side of the equal sign? It's on both. You don't want it on both sides. So let's get rid of one of them. Which one do I get rid of?
3.
The 3? Now you could get rid of any one you want, but I want to get rid of that 3L by subtracting 3L. And when I do to one side, I do to the other. Now I cannot subtract 3L with the 5, but I could subtract it with the other L, with the 5L. So I'm going to actually subtract 3L from the 5L. And 3L take away 5L, that is 2L. Now let me bring down the rest. This is a positive 2L. There's a 5 right here. The equal sign comes down. And there's a y right there. If I were solving for y, if it said solve for y, this would be it. Y equals this. But it doesn't say solve for y, it's solve for L. So I'm working on getting L by itself on the right side. It used to be on both sides. Now it's just on the right side. So right here, we're going to get rid of that 5 first. So we're going to subtract 5, subtract 5. This cancels. We have the equal sign. We have 2L on the right side. We have y minus 5 on the left side. So for my final step to get L by itself, I need to get rid of that multiplication of 2 by dividing by 2, divided the whole thing by 2. L equals y minus 5, all divided by 2. That's your answer. Of course, it's better to write the L on the left side. L equals y minus 5, all divided by 2. And there is no additional statement to say because the denominator is a nice number, 2. So this is a video on the even ones. You guys should do the odd ones. Both even and odd questions will be posted by the end of today.